Bismillahirrahmanirrahim. Welcome back, students. So, we are on the online lecture number 10, part 2 of the Programming Fundamental course. So, we are going to continue our discussion on functions with reference parameters. We are going to study some more examples. We are going to run some more C++ program. So the more we write program, the more we run program, the better our understanding will be. So with that, in the previous lecture, or in the part 1 of the reference parameter lecture, we were exploring the reference parameter and the value returning function. So today we are going to continue our discussion on discussing the difference between reference and the value returning parameter. So with that, I'm going to jump straight to the slide. Okay, so value and reference parameter and memory location. So it is very important to understand the difference between the value and the reference parameter. Remember, parameter is just another name for a variable. So if you do not understand about these differences, so it will be very difficult for you people to do programming or to solve real world programming task. So when a function is called, memory for its formal parameters. Now formal parameters is just another name for arguments. So whenever you have a user defined function and you call that function, memory for its formal parameters, like parameters that are in the parentheses, and variables declared in the body of the function called the local variables, which are only visible to that particular function. So a memory is allocated in the function data area. So I repeat, whenever you call a function, the memory is allocated for formal parameters as well as for the local variables in the function data area. So you have some area inside your memory or RAM, and you allocate a particular data. So that is like that particular area is area for local variables and for the arguments or for the function formal parameters. In case of a value parameter, so if you have a value parameters, you are not using the function, the value of actual parameter is copied into the memory cell of its corresponding formal parameter. So remember, actual parameter is just another name for the parameters or for the variable that are used in calling function. So in case of value parameter, the value of actual parameter is just copied. So you make a copy into the memory cell of its corresponding formal parameter. So you get a copy and give that copy or store that copy in the formal parameters. But in case of the reference parameter, if you have a reference variable, if you are using the ampersand sign with your variable, the address of actual parameter is passed to the formal parameter. So in this case, we are not making a copy, but we are getting the address of actual parameter, the address of the parameters, and that address is copied into the formal parameter or into the argument. Content of formal parameter is an address. So you get an address, you do not get the value of a variable. During the program execution, changes made by formal parameter permanently change the value of actual parameter. So if a formal parameter change something, that is reflected in the value of actual parameter. Why? Because now you have an address. So address points to the same area where actual parameter is pointing to, or where actual parameter has the value, the variable value. So if you have an address, if you use that address and change the variable data, then that change will permanently be reflected the value of the actual parameters or the value of parameters. String variables like if stream and off stream should be passed by a reference to the function. So we haven't discussed about if stream and off stream, but they should be passed as a reference to a function. All right, so with that, let us move ahead and let us see another example. The more we run examples, the more we run computer programs, the better our understanding will be. So this course is all about doing practical work. So you should type this program by your own self and then run this program, and then you will get a better idea of how program works, or what are the reference variable and what are the common variable, what is passed by reference and what is passed by value. So once again, we start our program by hash including the iostream file, and then we are using the namespace, standard namespace called std. We have two function prototypes. The first one is function 1. So we have function 1, and this is accepting a simple variable. So a copy of variable will be copied to the variable a, and then we are using a reference parameter or reference variable. Here b will store the address of the variable which is passing an address to the b variable, and we have another uh, uh, variable called v. Then we have another function called function 2, having a return type of void. Here we are using two reference variables or reference parameter. Remember, reference parameter, reference variables are both same thing. Whatever you call it doesn't matter. So we have a reference variable x and a simple variable y and a reference variable w. So remember, these reference variable will copy the address, will store the address of variable, whereas y will store a copy of the content of a variable, that is calling this function 2. Okay, we start our main program by using this main function, and then we declare two variables, variable num1, num2, and then we use another character variable ch. Num1 and num2 are integer, whereas ch is character. We assign some data to num1. So num1 gets the value of 10, whereas num2 gets the value of 15. Remember, this is assignment operator, this is not equal to operator. So a value 10 is assigned to or copied to num1, whereas value 15 is assigned to num2, and the character a is assigned to the variable ch. So with that, we move on, and inside the main function, line number 4, we display num1, and then we display num2, and then we display the ch character. So whatever is inside num1, 2, num2 and ch is displayed on the screen. And then in function 1 we pass num1, num2 and ch, and then in the next line we once again display the value of num1, num2 and ch. So what is happening in function 1? That is what makes this function 1 interesting. So remember, function 1 is accepting the address of the middle variable. Here in our case we are passing num2, the address of num2, whereas a copy of num1 and ch will be made. So when we call this function 1, so function 1 is here. So a gets the copy of num1 and b gets the address of num2, whereas v gets the copy of ch variable. So remember, now we have the address of num2 in b. So b and num2 here both are pointing to the same data. So both have the same address. So they are pointing to the same memory location because we have the address of num2 here. So inside this function 1 we declare another variable called 1, assign the value of a, which is I think 10, to num1, incremented, we multiply b by 2. So remember, this change will also be reflected in the main function because here we have got the value of the address of num2. We assign b to the variable v, and then we display these variables. Inside function 1 we display the value of a, the value of b, and the value of v variable, and we also displayed the one variable. So here if we see that whatever changes made to num and ch will not be reflected, whereas the changes made in num2 by this function 1 will be reflected over here. So we are multiplying b with 2, so that change will be also reflected with num2. So num2 also gets multiplied with 2. So the value inside num2, which is 15, gets multiplied by 2, because here we have the address. So changes directly are reflected in the main function. And then we call function 2. Here we in function 2 we pass the address of the first variable and the last parameter, whereas we pass just a value to the middle variable. So here we are passing the address of num2, the address of ch, and then a simple value, and then we are displaying the value of num1, num2, and ch. So here inside function 2, x gets the address of num2, y gets a simple value of 25, and w gets the address of ch. So if we change x or if we change w, so these changes will be reflected in the main function, because here this function 2 has addresses of num2 and ch. So if we display them, and later on if we display them in the main function, you will see these changes are also made in the actual function. So alright, so with that, to see the time, okay, we still have time to run this program. Okay, so let us run this program. So first we are in the main function where the value of num1 is 10, the value of num2 is 15, and ch is a. Then inside function 1 we display the value of a, b, v, and 1, which are 11, 15, and 30. So after function 1 gets executed, num1 is same because we copy the value of num1. Num2 gets changes because here b is having the address of num2, whereas ch is still unaffected because we copied the value of ch to this function. So here we change the value, but this is not reflected in the main function. Only the address of a variable which is passed, which is num2, so this num2 value gets changed because here we passed the reference of num2, the address of num2. So using this address we change the value of b. So b and num2 are pointing to the same variable, so that is why, because both of them are pointing to same location, so the values or changes are reflected both in main function or in function 1. So then inside function 2 we inside function 2, so let me change. So inside function 2 we have x31, y50, and wg, but after function 2 gets executed we have num1 10, num2 gets changed because why? Because we are passing the address of num2, and ch also gets changed to g because here the w and ch are both pointing to the same memory location, and here num2 and x are both pointing to the same memory location. So just before line 1 executes, memory is allocated only for the variable of the function main. So num1 gets a value, num2 gets a value, and ch also gets a value. This memory is not initialized. After line 3 executes, the variable are as shown in figure number 7.1. So now after line number 3 gets executed, these have the value. Num1 have 10, num2 have 15, and ch have a. So after displaying these value, you get the output at line number 4 inside main function. Num1 is 10, num2 is 15, and ch is a. So just before line 9 executes, the variable r as shown in figure 7.2. So here is function 1 where a get the copy of 10 and then b get the address of num2 and we get the copy of ch, and 1 has nothing so far. After that we initialize 1 to 10. So here you can see num2 and b are pointing to the same location. So changes made by b will also be reflected in num2. So after line 10, a gets incremented. So the changes are reflected here, but these are local variables and the value changes will not be reflected in the main function. So a is hidden from the main function. But in case of num2 and b, we have addresses, so address of num2, so this changes will also be reflected in the main function. Okay, after line number 11, b gets multiplied by 2, so this change is reflected in the main function because here b is pointing to the same memory location, to the memory location where num2 is pointing to. So after line number 12, v is assigned to b, but once again because we have just a copy, so v acts as a local variable and changes will also only reflected in function 1. And then line number 13 produces the following output. But when you call the after the execution of line number 13, control goes back to line number 6 and memory located for the variable function 1 is deallocated. Figure number 7.7 shows the value of variable for the function main. So then function 1 variables are deallocated, but main function value still retains. So num1 has 10, num2 has 30, and ch has a. And then similarly you call function 2, pass the addresses, x point to num2, w point to ch. So changes made here in x and w will be reflected here in num2 and ch. So just as you can see, num2 gets changes and ch also get changes. But if you change y, so this change will not be reflected because here we are just making changes to the copy of a variable, not to the actual variable. So the ch also gets changed after the function 2 is executed. And then you execute the function 2, the variables inside function 2 are deallocated, but the variables inside the main function still retains, and you have the value 10 for num1, 31 for num2, and g for ch, and this is the output. So with that, I'm going to end this lecture. If you have some problem, you can post it on the Google group. I'll see you inshallah in the next lecture. Till then, take care and